algorithm works most efficiently if it uses a small number of strategies that applies in all situations. So algorithms do not resort to techniques, such as the use of near doubles, that are efficient for a few cases but not useful in the majority of cases. The benefit of an algorithm is that it can become an automated process that, once understood, provides an accurate and efficient means to finding a solution. Algorithms for addition and subtraction should not be introduced until students have started to develop a familiarity with basic additions and subtractions to 20. Most addition and subtraction algorithms rely on place values for their operations. To have the ability to line up numbers in their place value column is a prerequisite to the introductions of both the addition and subtraction algorithms. It is essential that students can do all the additions in the addition table for two single-digit numbers before they progress to larger numbers. Fluency with the addition table provides a milestone for understanding for the student and a key stage in the student's development of addition basic facts. The more fluent they are with the table, the easier the student will find addition and subtraction in the future. The learning objective will be for students to use appropriate language, use materials or symbols to represent mathematical ideas, select and use appropriate mental or written strategies to solve problems, use mental and written strategies for addition and subtraction involving 2, 3, 4 and 5 digit numbers. Here is a place value chart. By writing the numbers in their right column, student can easily understand the concept of the number's place value. If the addition facts have been introduced and written using a vertical recording, the only new thinking needed to extend is an ability to deal with the tens and the hundreds. Materials can be used to establish the connections. Here I'm putting 8 and 4 cubes of 1s in the 1 column, 7 and 5 sticks of 10s, and 2 100 blocks. When more than 10 cubes result in the addition of the 1s, children can use their basic facts to give the total 8 plus 4 equals 12, leave the number of 1s in the 1s place and bundle the 10 blocks to form one 10 stick. Now the 10s. We know 7 plus 5 plus 1 equals 13. That is 13 tens. We then can bundle the 10 tens to make 100 blocks. This leaves us with 300s and 3 tens, so our total is 332, or as 300s, 3 tens and 2 1s. I am now going to show you the 3-step cycle for addition. The cycle will rotate clockwise from place values to basic facts, then renaming. Place value and renaming are simply combined with basic facts knowledge to provide a meaningful process that proceeds place by place. Let's start with addition algorithm for whole numbers. For example, 235 plus 492, using place value, basic facts, and renaming. First, by starting with the smallest place value, the 1s column. We know that 5 1s plus 2 1s equals 7 1s. That's 5 plus 2 equals 7. Equals to 7 1s. Now for the tens columns. We know that 3 tens plus 9 tens equal 12 tens. 3 plus 9 equals 12. We need to rename 12 tens as 100s and 2 tens, leaving the 2 tens in the tens and the 100s in the 100s. Lastly, the hundreds columns. We know that 100s plus 200s plus 400s equals 700s. That's 1 plus 2 plus 4 equals 7. We did not need to rename this. Subtraction is usually introduced following the learning of addition, building from the concept and basic facts through the use of materials to the written process in a similar manner. The cycle of steps required for subtraction is place value, renaming, and basic facts. Let's use these 3-digit numbers for example. 627 take away 135 by using place value, renaming, and basic facts. Like addition, we start from right to left, starting with the ones column. We do not need to rename as there are enough ones to take away 5. 7 ones take away 5 ones equals 2 ones. 7 take away 5 equals 2. Next is the tens column. There are not enough tens to take away 3, so we need more. We need to rename 100s to 10 tens. 10 tens plus 2 tens equals 12 tens. That's 12 tens take away 3 tens equal 9 tens. 12 take away 3 equals 9. Now for the hundreds column. We do not need to rename as there are enough hundreds to take away 1. 5 hundreds take away 1 hundreds equals 4 hundreds. 5 take away 1 equals 4. Therefore, 627 take away 135 equals to 492. And here are some misconceptions and difficulties that children may have with algorithms.